Hi guys, welcome back to the CS classroom. Today what we're going to do is we're going to talk about topic 4. This is going to be a longer video. It's going to focus on the programming questions, particularly on the SL exam. So we're going to cover how to do trace tables, how to analyze flowcharts, and how to approach IB programming problems, as well as pseudocode conventions. Now we're not going to cover some of the other sort of ancillary topics like sorting, searching, and Gantt charts. I just kind of want this to focus on programming. Also, I'm not going to teach you how to program. Mainly, I'm going to focus on teaching you how to program for the IB specifically. So if you need to learn how basic programming concepts work, like loops, conditionals, if statements, arrays, stuff like that, you can actually check out my Intro to Python playlist where I cover all of these in detail. And also, pseudocode is not the best place to learn how to program because you can't really see you can't really get any output from the code that you type in. Now, some of the difficulties with topic 4 are the fact that there's really no good pseudocode guide. As a teacher, the only way I knew how to accurately write pseudocode was by looking through old exams, so specifically looking at mark schemes of old exams. There's also no real curriculum. So there is a course guide, but it's fairly broad and open-ended. So it's unclear exactly what it is you need to be able to do in pseudocode, or really just for the IB exam in general, without, again, looking at old exams and looking at the mark schemes. Additionally, also, questions can often be unclear. Part of this is due to the fact that questions are just unclear, and they're just written poorly in general. But also, the IB examiners have a certain way or a certain method by which they write their questions and by which they mark answers. So it takes some time to get to know the exam. Additionally, mark schemes have slight differences in style. So for example, a mark scheme, particularly if you look at the year in which they're written, the mark schemes from 2016, for example, are written with a slightly different style than those from 2021 or 2022. Now, this isn't a major difference. It's not that big of a deal, but it is important to take into account, particularly when you're trying to figure out how to answer long word problems. Finally, there's not really an official textbook. So the picture on the right here is probably the textbook that you've seen, but it's actually not an official IB textbook. And it has a lot of information that's not particularly useful because it was meant to not only cover the curriculum for 2014 and beyond, but also all the content for the curriculum before that. So it can be slightly confusing. Oftentimes, the questions or the exercises and the content covered are either just too advanced or irrelevant to the exam. And it's really not that great of a guide. I mean, there are certain things you can take away from it, but I would use it as a resource, but not your focus in terms of studying for topic 4 and the IB exam in general. So particularly for topic 4, you're going to be answering your questions in pseudocode. And in general, pseudocode is any method that can be used to represent programming concepts. And oftentimes, pseudocode is used to plan algorithms. So it's just an example of pseudocode would just be you writing down in words how your algorithm is going to work. Or maybe just using some keywords for, okay, here's a loop, inside this loop, this is going to be there, et cetera, et cetera. There's no strict syntax you need to adhere to. Additionally, pseudocode is just, again, a way to plan. It can't be executed. But the issue you run into with IB pseudocode is that it's sort of this made-up language whose syntax you need to adhere to very strictly, which generally isn't the case for pseudocode. So IB has made up its own non-functional language, and you need to know how to follow the syntax of that language and how to write code using that language. Part of the reason for this is because so different teachers will teach different programming languages. And this is supposed to be kind of a lingua franca, I guess, between all those different languages. However, the pseudocode that IB uses is heavily based in Java. I don't know if this is still the case, but I do know that in older mark schemes, it was explicitly written that if an answer was written in Java as opposed to pseudocode, it was acceptable. And this would kind of make sense because particularly, I think it's option D on paper 2, is just Java object-oriented programming anyways. So I would stick to pseudocode. I still wouldn't write in Java unless you're doing it on paper 2, but that's kind of what the origin of pseudocode is. And again, it's really important to memorize the syntax and keywords. Now, what I'm going to do in this slide, like in the slideshow or in this video in general, is kind of go through some of the most fundamental tasks for the IB exam. Iterating through an array, finding the maximum and minimum in an array, calculating the sum and average of values in an array, searching an array for certain values or ranges of values, finding the common elements between arrays, and doing all these things using collections, which is, as you may know, is another data structure we can use in the IB exam. How to transfer data between both data structures, understanding and working with methods, just general like analyzing IB problems, using mod and div to solve problems, and validation of user input. Now, the questions you encounter on the IB exam are in most cases not going to be exactly these, but if you can do all these things and you understand how to do all these things, then you'll be well prepared to tackle anything that the IB exam throws at you. So we're going to start off by talking about arrays. What's important to note is that arrays in pseudocode are of a fixed length. So if you're coming from a language like Python, which utilizes lists, which you can append stuff to, this is not the same. So arrays in IB are generally pre-initialized and pre-created. So they're given to you basically with the number of spaces that you need. And if you do need to put information or need to put data into an array, you're not going to use append. You can just go ahead and access whatever index you need and put data in there. So it's a sort of weird thing where like you can't really change the size of an array, but you still end up having all of the positions or all the locations you need in the array. It's as big as you need it to be. Also, we can access length, the length property or attribute, and this will just give you the number of elements that are in the array. And this is universally accessible in any question. Now, array locations are contiguously located in memory. That means that data is located right next to each other, which allows for empty data locations, which means that arrays aren't always the most efficient solution. But knowing all of this, let's go ahead and solve some problems using arrays. Okay, guys, so what we're going to do is start with some basic tasks involving arrays. Now, again, the emphasis here is going to be on how to complete these tasks using pseudocode. You should generally be able to do these things using the programming language of your choice. I'll still explain how things work, but again, the emphasis is on pseudocode syntax and doing this for the IB exam. So let's get started. First thing we want to do is iterate through an array. So comments can be written in pseudocode with the double slash. This is our task. Let's say that we have an array. An array can be specified either as a variable normally would be in capital letters, like so, or we could have nums and we could specify the number of elements in an array. So let's say we have an array with 8 elements and I want to print out every element in that array. So we're going to have to use a loop. Perhaps the most common loop on the IB exam is going to be, I guess it's not, I can't really call it a for loop, but it pretty much works the same. I'm going to say loop I from 0 to nums.length minus 1. End loop. And then my code that will be subject to the loop is going to go inside right here. So I is going to be our counter. Z is going to be, or 0 is going to be the first value that I will have. And nums.length minus 1 is just going to be 7. This is going to represent the last element in the array. So then what I would do is I would want to, basically I want to print out every value in the array. So I'm going to do output and then nums I. As I said, all variables in pseudocode are going to be capital letters. So, and additionally, like anytime we have a loop, we're going to have loop and then end loop. So this will show where the code that's to be repeated stops. And I think part of this as well is just because people have really bad handwriting on the exam. So it makes it really clear like what's going to be in a loop and what's not going to be. Now, alternatively, we do have while loops in IB pseudocode. However, they're just less commonly used. The way we might do a while loop is we just say j equals 0. Loop while j is less than nums.length minus 1. Output nums j, and then end loop. Oh, we also need to do j equals j plus 1. Now, in other programming languages, you can do something like j plus equals 1 or j plus plus to increment. That doesn't work in pseudocode. You need to do this in order to increment your elements. So this is how we can iterate through an array in pseudocode and print out the output. Or really in here, we could do whatever code, or you could put whatever code we need to repetitively complete a task. Now the next thing we want to do is find the maximum and minimum in an array. So what I'm going to do actually is I'm just going to erase this, and then I'm just going to create an array. I'm just going to give this array some values. So I'll say like 5, 9, -1, 12, 13, 51, -6. And the idea is I want to find the like average, or this, well actually sorry, the maximum and minimum. So what I'm going to do is I'm going to set a value. I'm going to say max is equal to the first element. And this is just so we're not using an artificial value like 0, which doesn't exist in the array. So let's say max equals nums 0, starting at 5. And I'm going to loop through nums. I'm going to say loop I from 0 to nums length -1. And I'm going to check each value, and if nums I, so if any subsequent values in nums are greater than max, we're going to change max to that. So we're going to go through each value in this array. So we'll go to 5 first, that's num 0. And then, so we're going to say, or really we don't even have to, I mean, we'll say is num 0 greater than max? It's not, because they're the same, because we're starting from 0. We could even start from 1 if we wanted to. But it's not, so we're just going to keep max the same. And then we'll go to nums 1. So if we go to nums 1, we have 9. 9 is greater than the current max, which is 5. So that means that max becomes 9. Then we go to -1. -1 is not greater than 9, so max stays the same. Then we go to 12. 12 is greater than max, which is 9. So we change max to 12. So we're going to each value in the array, and every time we find a value greater than the current max, we change max to whatever that value is. So by the end, we should have 51. Also, one thing to keep in mind is right here we're using an if statement, and that is inside our loop. We have if, our condition, and then. Here we have the code in the if statement. We're going to follow that up with end if, and then end loop. Now end if is showing where the code is making sure that we know what code is subject to the if statement, and end loop is doing the same for the loop. Now we could do something like output, the max is, comma, and then our variable max. And this will work. This is how we can output both a message and a variable, a value. So if we wanted to find the minimum, we would just do the opposite. So right here we have nums I is greater than max. We would change this to nums I is less than max. So we're going to start max out with num 0, or max is going to be 5 first. And then we're going to go to the next element. We're going to say, is that less than max? No, then do nothing. Go to the next element, is that less than max? Yes, and change max to that. Although we can actually change the name to min. I feel like that would make a lot more sense, right? But all we really did was change this from greater than to less than. And that's how you find the max and min. Now next we want to calculate the sum and average of values in an array. Another common task, I'm just going to edit the existing code I have. We don't really need this anymore. But we need a variable called sum, so we're going to say sum equals 0. This is going to hold our running sum. So we're going to go to each element, and every time we get to each element, we're going to add that to sum. So by the end, we'll have 5 plus 9 plus -1 plus 12 plus 13 plus 51 plus -6. So the way we're going to do that is we're going to do sum equals sum plus nums I. And what this basically means is that we're going to say sum is equal to the current value of sum plus nums I. So first we would have 0 plus 5. So the sum would be 5. Then we would have 5 plus 9, and the sum would be 14. Then we would have 14 plus negative 1. The sum would be 13. And we have 13 plus 12, and the sum would be 25, and so forth. Now, if we just wanted to calculate the average, we could say AVG for average equals sum slash nums.length. We can output the average is AVG. Next, search an array for certain values or ranges of values in an array. So let's say we want to print out all the numbers greater than, or all the numbers less than 0. Okay? We could just say if nums I is less than 0, then output, well, we can output that the index of that value, or we can just output nums I. Easy way. Let's say we want all numbers that are greater than 0, but less than 15. So whatever numbers meet both these conditions, we'll output them. Notice here we used and. So this is just and the word, and it's in lowercase. Optionally, we could also do or, which follows a similar syntax, just or, but in lowercase. Now we can also do something like not. So we can have and right here, and we could just put parentheses around these and do not if we wanted to. And that'd be the opposite of whatever this is. So so we want to print out a value that is not greater than 0 and less than 15. Or we could just say if nums does not equal 9, then just print it out. That works too. Those are some really common Boolean operators that we can use. Again, you can look at my study guide to see like a full and pretty concise list of what all of these are. But these should be pretty straightforward. Now finally, find the common elements between arrays. This is one of my favorite examples. Let's say we have an array of the names of people who speak French. You can say French, or well, no, we'll say John, Ali, Chen, and Jose. And we have an array of the names of people who speak Spanish. We'll have, let's say, Jeff, Sarah, Ali, and John. Well, we'll make it different. We'll just say Samir. Okay, I had trouble thinking of a name there for a second. What we want to do is we want to find the values that are common between both of these arrays. So we want to find that value and we want to print that value out. So in this case, that should just be Ali. So what we're going to do is we're going to say loop I from 0 to French dot length minus 1. And inside that, we're going to tab and we're going to do loop J. We're going to do loop J from 0 to Spanish dot length minus 1. We're going to say if French I equals Spanish J, then output French I mean, you could really output either one because the idea is that they're the same. And if, and loop again. And yeah, basically we're going to each element of French in the first array. And then for each element, we're going to look through the entire Spanish array and see if it exists there. So for example, when I equals 0, we're going to go to French 0. And we're going to look through the entire Spanish loop and see if any of these are equal to John. And we'll do the same thing for Ali, and then Chen, and then Jose. So beyond just being a pretty common task, this is a good example of how you'd use nested loops in pseudocode. Now, tabbing isn't strictly mandated. It's not like in Python where if you don't tab your code, everything just doesn't work. But I recommend always tabbing because just even if you have the end loops, it just makes your code much more easy, and it gives your examiner, like if your examiner is having an easier time reading your code, odds are you're probably going to get a better grade just because it's just clear what your answer is. And they're not going to make mistakes in marking you. So yeah, basically indent, use end loops and ifs. Sometimes these, especially with nested loops, things can get really messy. So those are the most common array related tasks. Now, what we're actually going to do after we've covered collections and methods is we're going to solve actual IB problems using what we've gone through here. So if this was easy for you, or you want to see something a bit more complex, don't fear, you can always skip ahead, or you can just continue going through the video and just be rest assured that we will go through some actual IB questions. Okay, so collections are different from arrays in a number of ways. The first is that they don't have a fixed length, so we can't add items to collections and also remove items, although I don't think that's generally done in the IB exam. So items can be added dynamically, and each location in a collection points to the next. So you'll have a piece of data and then a pointer to the next piece of data or the next memory location. So the data in a collection is spread out throughout the RAM, with each element in a collection pointing to the address of the next. And we can only iterate through a collection or traverse a collection using specific methods on that collection, because a collection represents a type of object. So basically, collections don't have a fixed length. Items can be added dynamically, and the only way we can go through them is by using functions, like specific functions or methods that correspond to collections. So let's get started. I'm going to go ahead and erase this. The first task we're going to try to do is iterate through a collection. So when we're dealing with collections in pseudocode, they're generally indicated by curly brackets. So for example, a collection might look like this. Those are square brackets. So we might have a collection that looks like 5, 6, 7, 9. Now, generally, one of the distinguishing features of collections is that we can have elements of different data types. So we could have an integer, we could just have a string, and then we could have, I suppose, a Boolean. However, in most cases, I think in the majority of cases, you'll see collections with the same type of elements, or the same data type, really. So we have a collection here called B, which is specified by curly braces, which indicates a collection. Now, before we work with any collection or traverse collection, we want to do b.reset next. What this does is this basically says that we are starting out before the first element. So basically each piece of data or each element in a collection points to the next. But additionally, when we're going through a collection, we are going to have the computer has its own position, basically, or we have our own position. So b.reset next positions us right before the first element. If we do b.get next after that, that moves us to 5. If we have if we run b.get next again, that's going to put us at 8, and then b.get next again is going to put us at 7, and then so on. Now, what we could also do, let's say that we have done b.reset next, we're right here before the first element. If we do x equals b.get next, then not only are we moving to 5, but the variable x is also going to be equal to 5. So if we were to output x, then we would just be outputting 5. Now, if we did b.get next, if we did y equals b.get next, then we'd be moving to 8. That would move us to 8, and then y would be equal to 8. So if we output x and then y, we would have 5, and then we would have 8. So Basically, get next is how we can traverse an array, this method right here. Now, it's pretty tedious, especially if you have a collection with like 250 elements to try to do get next 250 times. So instead what we're going to do is we're going to use a loop. And I'm just going to set this down here. We're always going to start with b.resetNext, and then we're going to do loop while b.hasNext. Let's say num equals b.getNext. Basically how this is working is we have b.resetNext right here. So that starts us off right before the first element. And then we're going to say while b.hasNext. So if there is an element after where we currently are, then we're going to do getNext. So we're right here, we check, is there an element after this? There is. So then we can say num equals 5. So that means that now we're right here. Then we go back, and so we do num equals 5, and we could actually just output num really if you want to. So the first value we're going to output is 5, right? Because we checked, we start at the beginning, we checked, is there an element after this? There is. So then we did b.getNext, num was equal to that, and we're at 5, and we output that. So now we're going to go back and we're going to check. Now that we're here, is b.hasNext true? Is there an element after this? And there is. So we're going to continue, and we're going to say num equals b.getNext, which is just going to give us 8. We're going to keep doing that. HasNext, with hasNext, every time we are at a particular element, it allows us to peek ahead and see whether there's an element after that, returning true if there is and false if they're not. So by the time we get to 9, so let's say we have num equals b.getNext, output 9. Then we're going to go back right up here, and we're going to check, is there one after this? And b.hasNext is going to be false. So we're going to move to whatever code is after the loop. So hasNext is what allows us to progress, and getNext moves us along to each element, storing that element in whatever variable we decide simultaneously. And this is how we iterate through a collection. So if you want to find the maximum and minimum in a collection, it's a pretty similar process to what we did with arrays. So basically what we're going to do is we're going to say, let's say max equals, yeah, what's up? Sorry.
In addition to the runway array?
Okay, so right here we're going to set a variable called max, and I'm probably not going to set it to 0. I think I'm going to do, well, we're going to have b.resetNext, and then I'm going to do b.getNext. So for example, in this array, what that would do is that would get the first element here, which is 5. So that means this would be our current position. So once I've done that, I'm going to say if, well, we'll say num equals b.getNext, and I will say if num, or yeah, if num is greater than max, then max is going to be equal to num. And if. So what I would do, so one of the things to keep in mind as well is I'm using this variable, I'm storing the result of b.getNext into num, and I'm basically using that num throughout my code. If I didn't do that, if I just did b.getNext, so if I did this, for example, basically what would happen is every time I did b.getNext, that would move me forward in the array. So right here I said max equals b.getNext, meaning max equals 5. So when I start this loop, I'm starting at 5, and then basically the first value of num is going to be 8, right? But if I did getNext again, that would take me to 7. And then if I did getNext again, that means max would equal 9. So the sort of unique thing about getNext is every time we call it, it not only not only changes our position in the collection, but it also stores the result in a variable. It does those two things. So that's why I set it equal to num, because I really just wanted to move one position ahead. And then we're going to have num is greater than max right here, and num right here. And then I could just output max. And then, or it would just be similar to the arrays. I would just change that to less. And maybe we'd have like min for minimum. So really, like, obviously the loop structure and using the methods is different from arrays, but just this aspect right here of get next is probably the most important thing to consider when you're trying to find the maximum and minimum. Now, let's say we want to calculate the sum or average of values in a collection. Again, similar to arrays, we'd have sum equals 0. In this case, we could just have sum equals sum plus get next. And then we could output sum. However, when we normally have an array, we'll do, array.length, or we'll be able to use the length property in order to find out how many elements are in the data structure. In this case, an array or collection, and then divide the sum by that to get our average. However, we don't have that. Collections don't really have a determinate length. There's no way to find out how many are in a collection besides iterating through the whole thing and counting. So in order for us to calculate the average so that we can divide our sum by that value, we're going to say count equals 0. Count equals count plus 1. So every time we are going to another element or changing position, we're also adding 1 to count. And then we can do sum divided by count. So basically every time we move to a new position in our collection, we're adding 1 to count. So by the end, we have the total number of elements in that collection, and we can do sum divided by count. So that's how you find a sum and an average. The sum's pretty straightforward. It's basically just this line of code. But getting the count is the difference from an array. Next, search an array for certain values or ranges of values. I'd probably say the main distinguishing factor is what we saw with max and min. So let's say you just want to print out any values greater than 5. We'd say num equals b.getNext. If num is greater than 5, then let's just say output num. And if. And then we're not really going to output anything else. So if statement still works the same as usual. Again, we're doing b.getNext, and we're setting the result to num, and then we're just using that variable throughout the rest of our code. And yeah, we can do other stuff like end num is less than 8, or whatever it is that we really want to do. Not a big deal. I'll go ahead and get rid of this because we don't need this at the moment. Find the common elements between collections. Now, we did this with arrays, right? So let's go ahead and kind of recreate that with collections. So let's say we have a collection of French speakers. So we've got John, Lee, Angel, and let's say we have Makar. We're going to have a list of Spanish speakers. These are all in collections. We're going to say, again, Jeff, Fernando, what's another name? Sophia, and Angel. So we want to find the common elements between both these collections, which should be Angel in this case. And we're just going to output it. So what we're going to do is we are going to make sure that we are at the beginning of both collections. So we're right here for both of them. To do that, we're going to do French.reset next. I recommend doing this before you ever try to iterate through any collection. It's just good practice. And I know I've seen in the mark scheme that there's usually like 1 point associated with this. And Spanish.reset next. Then we're going to do loop while French.hasNext. Loop while Spanish.hasNext. So what we're going to do right in here is we're going to say fur equals French.getNext. So it's going to move us to John, for example, the first time. And then we want to go through every element in Spanish that has next, in the Spanish collection, and see whether it's equal to fur. And then we're going to do that for Lee, and then Angel, and then Makar. So we'll say yes equals Spanish.getNext. If fr equals es, then output fr. And if, and loop, and loop. So same concept, except right here, we're just doing get next. So we're doing get next, and we're storing that in a variable for our French collection. And then each time we do that, we're going through the entire Spanish collection, and we're basically storing whatever we get each time in ES, and we're comparing that to FR. Now, one thing that we also need to do, so the idea is that each time we go through an element in the French collection, we're going through the entirety of the Spanish collection. So each time, before we do that, we're going to need to do Spanish.resetNext. So that way we're starting from the beginning each time. So we're getting our value from the French collection, we're resetting Spanish, we're going through the whole collection, we're checking whether any are equal to FR. If they are, we output it, and then we go back to the next element in the French collection, get that element, reset Spanish, so we're starting at the beginning, and go through it again. So yeah, this is probably one case in which reset next isn't just a formality, but is actually necessary in order to be able to go back and go through a collection one more time. And again, make sure that you use endif and end loop in the right place, so it's clear where these get nexts are positioned. Now, these are two super common tasks: transfer data from arrays to collections, and transfer data from collections to arrays. Let's go ahead and give that a shot. So let's say we have an array called score, an array called temps. We're going to have, let's see, 56, 79, 91, 92. We want to transfer this to an array called temps, or a collection called temps call, specified by our curly braces, and it's currently empty. What we're going to do first is we'll do temps call dot reset next, just to make sure we're starting at the beginning. There's no reason we really wouldn't. Actually, you know what? I don't think we even have to do this, because there's actually nothing in the collection. But in that case, let's just start with a loop. We're going to do loop I from 0 to temps.length -1. So we want to go to every element in temps, and each time we're going to do temps call dot add item temps I. Probably to make this clear, what we could do is we could say current temp equals temps I. And basically, when we want to add an item to a collection, we're going to use the add item method, and we're going to put what we want to add inside the parentheses. So you put cur temp. And we're going to do that for each item in temps until there are none left, until we get to the end. And that's actually pretty simple. Just use add item. So that's how we can easily go from an array to a collection. Now, going from a collection to an array is not particularly complex, but a little bit more complicated. So let's say that temps is now empty, and instead this data is in temps call. So what we're going to do is we're going to do temps call dot reset next, as we always do. Loop while temps call dot has next. We're also going to want a count equals 0. And we're going to say per temp equals temps call dot get next. So this is actually pretty classic, except for the count up here. This should be pretty familiar. But one thing you have to remember about IB pseudocode is that right here, this is empty. I mean, really in pseudocode, it could be written like this. But in any question we're given, we're going to have as many positions as we need. So we can assume that we already have something like this, right? So we've got an array that has 4 locations, which are already pre-initialized. So maybe it looks something like this. That's what we would be given in an IB question in IB pseudocode. It's just up to us to change these to whatever we want to. So we're going to have a count that's going to start at 0. And here we've gotten our current value of the current value from our temps call, our collection, stored it in the current temp variable. So what we're going to do is we're going to do temps count equals cur temp. And then we're going to add 1 to count each time. Because remember that count, this is a while loop right here. So we don't have any variable that's automatically being incremented. So each time we're getting the next value in the collection, we're putting that into we're putting that into the array. And then we're adding 1 to count. So that the next time we will add we'll add a value from our collection into the next location in the array. So we're going to go from 56 to temps 0, 79 to temps 1, 72 to temps 2, 91 to temps 2, and 92 to temps 3. And the indices of those arrays are determined by count, which is being added up each time, or rather incremented each time. And this is how you can transfer data from an array to a collection in IB pseudocode. So those are some of the most basic tasks for dealing with collections. Again, similar to arrays, if you understand how all of these work, you can tackle pretty much any task on the IBSL exam. Okay, so that's the end of part 1, and what I've decided will be a 3-part series. In the next part, I hope to cover methods, mod and div operators, and validation of user input. If there's some time left, we might also cover trace tables in that particular video, but I expect to cover all of the IB practice questions in the 3rd part in this series. If you'd like to see the next parts of this video or the next parts of my series on topic 4, please like this video and subscribe to the channel so you can get updates on that. Additionally, if you want to get kind of an easy to use study guide with all the information you need to pass the SL exam, including detailed information on topic 1, 2, 3, and a pseudocode study guide on topic 4. Stay tuned for a link to this study guide I'll be publishing online. It'll probably be about $3.99, but I hope it'll be super useful for you guys. Anyways, have a nice day.